Okay, so now we move on to number 25. What force must be exerted on the master cylinder of a hydraulic lift to support the weight of a 2,000 kilogram car, a large car, resting on the slave cylinder? The master cylinder has a 2 centimeter diameter and the slave cylinder has a 24 centimeter diameter. Alright, so we got to figure out what's going on here. We're talking about pressure in equals pressure out. So we have an enclosed fluid. So the pressure is going to be the same throughout, and that means force in over area in equals force out over area out, right? Breaking that down, we did that in class. Alright, so now we can take a look at this and say, alright, if we're going to do area, we need to know the area. Alright, the area of these two cylinders is going to be pi r squared. Alright, they didn't give us the radius, so radius equals diameter over 2. Okay, we can do this. We just have to make a little room here. Alright, so radius equals diameter over 2, so area in equals diameter over 2 squared, and that's 2 times 10 to the negative second meters. We have to get good at this, because we can't spend thousands of hours converting centimeters to meters all the time. So 2 times 10 to the negative second meters divided by 2 squared times pi. That's pi r squared. That gives us an area in of 3.14 times 10 to the negative fourth meters squared. Okay, that's cool. Same process with the outgoing diameter, so we just go through that whole process again, and we get 4.52 times 10 to the negative second square meters. Alright, so we have our two areas. That's good. Force in over area in equals force out over area out. Alright, so we should know things like maybe the force that we're talking about. It's a 2,000 kilogram car, so force out equals mg. The mass is 2,000 kilograms. The acceleration due to gravity is still 9.8 meters per second squared. So we get 1.96 times 10 to the fourth newtons is our force out. Okay, so one more time. Force in over area in equals force out over area out. Now we solve for the input force. What force do we have to put in order to lift this up? It's force out times the product of area in divided by area out. We did all of that, so we can just plug in our numbers. Force in equals the 1.96 times 10 to the fourth newtons times 3.14 times 10 to the negative fourth meters squared divided by 4.52 times 10 to the negative second meters squared. And believe it or not, with all those crazy big and small numbers, we run them all and we get an answer of 136 newtons. Hope that helps. Catch you later.